Mars, the frozen ghost of a once living world. For decades, humanity has dreamed of reviving it, of turning that dead desert into a second Earth. But can we really rewrite the destiny of an entire planet? Could technology, ambition, and sheer human will transform the impossible? This is the story of a dream so vast it defies science, and a question that may define the next century. Can we make Mars alive again? Mars is our next-door neighbor in the solar system, a world that mirrors our own in so many ways. Valleys once carved by rivers, mountains taller than Everest, and polar ice caps that glisten under the sun. It's not hard to see why humanity has long imagined setting foot there, building cities, and perhaps one day calling it home. But in reality, Mars is brutally inhospitable. Temperatures can plunge to minus 100 degrees Celsius. The air is so thin that your blood would boil without a pressure suit. Dust storms can blanket the entire planet for months. It's a world frozen in time, cold, desolate, and utterly alien. And yet within that harsh silence lies a tantalizing mystery. Billions of years ago, Mars may have looked more like Earth, with rivers, lakes, and maybe even oceans. Something changed. The atmosphere thinned, the magnetic field vanished, and the planet died. That haunting what-if continues to drive our curiosity today. So why terraform Mars? Why try to bring life back to a dead world? Because Earth's resources are finite, our population keeps growing, and our species, restless and ambitious, has always sought to go further. Terraforming Mars isn't just a scientific challenge, it's a statement of survival, a declaration that humanity refuses to remain bound to one fragile blue world. Mars is not just another planet. It's the ultimate test of our technology, our imagination, and our right to shape worlds beyond our own. Terraforming Mars. The idea sounds like pure science fiction, turning a frozen wasteland into a world with blue skies, flowing rivers, and breathable air. It's the kind of dream that would make even the boldest scientist hesitate. Yet, if we were to take the first steps, what would that actually look like? Step 1. Build the air. The first challenge is the atmosphere, or rather, the lack of it. Mars's thin blanket of gas is 95% carbon dioxide, but far too sparse to trap heat or sustain life. The pressure is less than 1% of Earth's. To create a warm, habitable world, we'd need to thicken that atmosphere. One idea: release the CO2 locked in the planet's polar ice caps and soil. By deploying massive orbital mirrors or using powerful nuclear reactors, we could heat the surface, releasing those gases and triggering a runaway greenhouse effect. As more CO2 enters the air, the planet warms, melting more ice, releasing even more gas, a feedback loop that could, theoretically, make Mars self-warming. But there's a catch. Even if we released every molecule of trapped CO2, it still might not be enough. So scientists propose importing extra greenhouse gases, compounds like perfluorocarbons, thousands of times more effective than CO2. They could be manufactured by robotic factories powered by the sun, slowly thickening the Martian sky over decades. Step 2. Bring the water. Once the air is in motion, the next ingredient is water, the essence of life. Mars already has it, frozen at the poles and hidden beneath the surface. If we warm the planet enough, that ice could melt, forming rivers, lakes, and shallow seas. Another radical idea: asteroid delivery. Redirecting icy comets or water-rich asteroids to crash into Mars could instantly add massive amounts of water and release energy to heat the planet further. It's dangerous, yes, but in the grand scale of terraforming, controlled impacts might be faster than waiting centuries for sunlight to do the job. Imagine that moment, the first Martian rain, falling after millions of years of silence. A world awakening. Step 3. Seed the life. With warmth, air, and water in place, Mars would still be sterile. That's where biology steps in. We'd begin with the smallest pioneers, genetically engineered microbes designed to survive radiation, low pressure, and freezing nights. Their job would be to convert carbon dioxide into oxygen, just as cyanobacteria did for Earth billions of years ago. Next, we'd introduce hardy plants, mosses, lichens, maybe even red-tinted algae that could spread across Martian soil. Over centuries, these lifeforms would reshape the air composition, enriching oxygen levels and stabilizing the ecosystem. Finally, in a distant future, when conditions are right, animals could follow. Insects, birds, perhaps even mammals. A full biosphere, reborn on a planet that once died. The scale of the dream. Every stage of this blueprint would take decades, even centuries. Terraforming Mars isn't a single project. It's a chain reaction of physics, chemistry, and biology, a planetary-scale symphony. It would require unimaginable energy, endless patience, and the cooperation of generations. But every great transformation in human history began with something equally impossible. For now, the blueprint exists only in simulations, laboratories, and the minds of dreamers. Yet, with every rocket launched, every rover crawling across the red sands, we inch closer to turning that dream into the blueprint of tomorrow. If we were to put a date on humanity's dream of transforming Mars, 2075 often surfaces in bold headlines, a milestone year, a symbolic horizon. But is it a realistic goal, or a hopeful illusion fueled by our obsession with progress? To make Mars habitable by 2075, we'd need to compress centuries of planetary engineering into just 5 decades. That means breakthroughs not just in rocket technology, but in energy production, material science, and artificial intelligence. Energy would be the heartbeat of the mission. Terraforming requires staggering power, enough to melt ice caps, drive chemical factories, and sustain billions of tons of atmospheric gas. Nuclear fusion, if mastered, could become the game changer, a near-limitless source of clean power for an entire planet. Without it, the idea collapses under its own energy demands. Robotics would carry the burden that humans cannot. Swarms of autonomous drones and rovers could construct solar arrays, mine Martian soil, and operate chemical plants, all without direct human supervision. These robotic colonies would become the planet's first settlers, preparing Mars for those who come later. Then comes biology. By 2075, advances in genetic engineering might allow us to design life tailored to Mars, organisms that thrive in low gravity, weak sunlight, and thin air. This new branch of synthetic life could do what natural evolution never had time to finish. NASA and SpaceX are already laying the groundwork. The Artemis program, Starship missions, and Mars habitat concepts are more than experiments. They're stepping stones toward planetary-scale transformation. Private ventures, research labs, and even nation-states are beginning to collaborate on what was once pure fantasy. Still, scientists are divided. Some call it the slow burn, insisting Mars terraforming would take centuries of patient effort. Others argue for the fast track, that exponential technology, driven by AI and fusion, could shatter all timelines. Perhaps the truth lies somewhere in between. 2075 may not be the year we walk under a blue Martian sky, but it could be the year humanity proves that the impossible no longer exists. Every dream worth chasing comes with a cost, and terraforming Mars may be the most expensive dream of all. Not just in money or time, but in the raw energy and moral weight it demands. Let's start with the physics. To transform Mars, humanity would need to unleash power on a planetary scale, enough to warm an entire world, melt polar ice caps, and drive atmospheric circulation. Estimates suggest it would take the energy output of all civilization for hundreds of years. That's not just a big number, it's nearly unimaginable. And even if we could generate that power, there's no guarantee of control. Altering a planet's climate isn't like tweaking a thermostat. Once we set change in motion, we might trigger consequences no simulation could predict: global dust storms, runaway greenhouse effects, or even chemical reactions that poison the very air we create. Mars could easily swing from frozen to fiery, from barren to toxic. But the hardest questions aren't scientific, they're ethical. What if Mars already harbors microbial life, hidden deep underground, clinging to warmth beneath the permafrost? By introducing Earth organisms, we could wipe out an entire alien biosphere before we even know it exists. Would that be colonization or extinction? Some argue Mars should be left untouched, a cosmic museum of natural history. Others see it as humanity's moral duty to bring life where there is none. It's a philosophical tug-of-war between preservation and creation, between humility and ambition. And beyond that looms a deeper issue. What gives us the right to reshape another world? If we couldn't protect our own planet from pollution and climate change, do we deserve a second chance on Mars? Terraforming could be our greatest triumph, or our most irreversible mistake. Because once we begin rewriting a planet's destiny, there's no turning back the page. Imagine it's the year 2075. The red planet is no longer silent. Where once there was dust, there are rivers, thin streams cutting through valleys long thought lifeless. Blue skies shimmer faintly through a hazy warmth. In the distance, domed cities rise like glass oases under the sun, connected by glistening railways and glowing fields of solar panels. Humanity has found a second dawn. Children born on Mars have never seen an Earth sunrise. To them, the soft hum of life support domes, the sight of twin moons above the horizon, and the whisper of artificial rain are simply home. The human race has expanded its definition of what world means. Beyond survival, something deeper has taken root, a sense of stewardship. Terraforming Mars was never just about escaping Earth's problems. It was about proving that life, in all its fragile beauty, can spread even into the coldest corners of the cosmos. There will be challenges still, adapting to low gravity, sustaining ecosystems, and learning to coexist with a planet we've reshaped. But standing on the Martian plains, watching the first forests sway beneath an alien sun, humanity will realize something profound. We've become architects of worlds. Mars will never be Earth. But perhaps that's the point. It will be a reminder that even in the face of the impossible, life finds a way, and the human spirit refuses to fade. The red planet will no longer be a symbol of desolation, but of what we can become when we dare to dream beyond the stars.